So in this section we deal with something that oftentimes seems confusing, but it's an incredibly important part of our study of chemistry. As we saw on that first slide worth of notes, depending on how many items we have of something, we will have some excess of one and just enough of the other. So if we consider those car tires and car bodies, if we have 8 car bodies, each one needs 4 tires, we would need 32 tires. But we actually have 48. So we have enough bodies to make cars, and that's actually what limits us into how many cars we can make, because we have 16 tires extra and we use up all the bodies. Same thing happens in any chemical reaction. When we mix 2 substances or we react 2 substances, we will have enough of one substance to use it all up, but there will be excess of another substance left over. And in this section, it's our job to find out which is used all up, and we call that the limiting reagent, and which we have excess, and we call that the excess reagent. To do that, like with any chemistry problem, we need to find out how many moles we have and how many moles we need. What we know is we have 2 grams of ammonia and 4 grams of oxygen. That's what we have. One of those will get all used up, one of those won't. In order to deal with that, we need to deal with how many moles of the substance. So we can figure out how many moles I'm just going to leave a blank because we don't know of ammonia, which is NH3. To find that, well, we have mass, 2 grams. We need to convert that into moles. To do that, we need the molar mass. So in ammonia, we have 1 nitrogen weighing 14.007 grams per mole, 3 hydrogens, each weighing 1.008, up to 3.024. Adding that up gives us a molar mass of 17.031 grams per mole. Going ahead now and finding how many moles of ammonia we have. Same calculation as it's always been, mass divided by molar mass, so 2.00 grams divide 17.031, which means we have 0.1174 moles of NH3. Now I'm just going to fill that into the blank, because that's going to come into play later. We're mixing that with 4 grams of oxygen, so we need to know how many moles of oxygen we have. Again, molar mass. Luckily, oxygen is just O2, so in that compound we have 2 oxygens, each weighing 15.999, so 31.998 grams per mole is our molar mass. And the number of moles of oxygen, 4 grams divided by 31.998 gives us 0.125 moles of oxygen. Now, this is not enough information to tell us which is the limiting and which is the excess reagent. Oftentimes, people look at this and say, oh, we have more oxygen, so ammonia must be the limiting reagent. That's not necessarily true. If we had 8 car bodies and 12 tires, oh, the car bodies must be the limiting reagent. Well, no, because 12 tires would fit on 3 cars because we need 4 tires for each car. We may not need a 1-to-1 ratio of moles in this chemical equation. So then we need to actually go ahead and make an assumption. We assume that one of the 2 is the limiting reagent, and we find out if that assumption is actually true. It does not matter which substance we assume. As we go through examples, I'll show you how this works out both ways, if our assumption is correct and if our assumption is false. So I'm just going to go ahead and assume that ammonia is the limiting reagent, and I abbreviate it LR. Now, assuming that that is the case, we would use up all of the ammonia. If we use up all the ammonia, we need to know how much oxygen that would actually take. So it's the same kind of calculation we deal with a straight stoichiometry problem. We have 0.1174 moles of NH3. We need to multiply that by the molar ratio. Looking back in the chemical equation, we have 4 moles of ammonia, 5 moles of O2. So 5 moles of O2, 4 moles NH3. Do the calculation, and we get that if we use up all the ammonia, we need 0.1468 moles of O2. And this 0.1468 moles of O2 is what we need if we use up all of our ammonia. Looking back, we actually only have 0.125 moles of O2. So we do not have enough O2 to use up all the NH3. Meaning, let me just say this a little nicer. In layman's terms, we don't have enough O2, meaning that O2 is the limiting reagent. So in actuality, our assumption was false when we said that ammonia was the limiting reagent, but that's okay. So now, because our assumption was false, we need to actually figure out how much ammonia is left over, because ammonia is the excess reagent, some of it will be left over. So now that we knowing that O2 is the limiting reagent, we need to do another mole conversion, mole ratio calculation to find out how much ammonia actually gets used up. So knowing that we use up all 0.125 moles of O2, same mole ratio, 5 and 4, except now, because we're dealing with O2, we'll have 4 moles NH3 on top, 5 moles O2 on the bottom. Calculate that out, that gives us 0.100, and I'm using 3 sig figs here because that's what we had in the question. 0.100 moles of NH3 left over, or excess. Sorry, not left over, excuse me. That's how many moles of NH3 get used. So then the real question is, how much excess NH3 do we have? Well, we had in total 0.1174 moles of it. We used up, we'll subtract off 0.100 moles, and gives us, so we have 0.0174 moles of ammonia as excess.